Forces Day 13. Friction. April 15th, presented to you by Mike Zhang, Gabriel Soot, and Stefan Monescu. What is friction? Well, friction occurs in our daily lives. Whether you're a competitive athlete, driving to school, or playing tug of war, friction is one force we can't live without. Friction is defined as the sliding of two surfaces across one another. Friction acts opposite to the motion or the attempted motion. For example, when I'm rubbing my hands together, friction is occurring.
Consider Newton's first law, which states that if a single force is applied to an object, it will continue in that direction of constant acceleration. But if I push this cart, you will see that eventually it slows down, meaning that there must be another force that is acting against the applied force, which causes it to slow down. This force is defined as friction.
Consider three situations. In example A, our cart is just sitting here by itself. No other force is acting upon it except the normal force of the table as well as the gravitational force of the earth. In situation B, we're pulling on the cart, but it is not yet moving. And finally, in situation C, we're pulling on the cart, and it's now moving with a constant velocity.
Situation A. All the forces are balanced, and there are only vertical forces acting on the system. Situation B. All the forces are balanced, since it's still not moving, but now there are vertical and horizontal forces acting on the object, applied force and friction. And we know that friction exists because there must be a force preventing the applied force we made from moving the object. In situation C, all the forces are again balanced, since the object is moving with constant velocity, and again, there are horizontal and vertical forces acting on the system. In conclusion, the net force for all three force diagrams was 0 for the horizontal and vertical positions because it does not accelerate in either direction.
Let us look again at situation C, this time of a force diagram and a force graph that measures how much force we applied on the system. And since the net force was applied on the object was 0, and we know this since the object was not accelerated in either direction, this graph also shows the force of friction that we're acting against our applied force. A small bump in the graph represents the time when the object starts moving from rest and moves with a constant velocity. As you can see, more force is required to make the object move than to keep it at a constant velocity. We define the force of friction acting on the system when a force is applied to the system but the system is still at rest, called static friction. And we define the force of friction acting on the system after it starts moving and the two object surfaces start slipping against each other as kinetic friction. As you can see, the force of static friction is adjustable, whereas the force of kinetic friction is constant. And if we applied more force in the object, then the system would start having a constant acceleration.
So, in conclusion, friction is a contact force that occurs when two objects that are pressed together try to slide against one another. If the surfaces are sliding relative to one another, we call the force kinetic friction. If the two surfaces are not slipping, we call the force static friction.